Hello everyone, today we're going to be investigating series and parallel circuits in AC. Let's jump right in. AC circuits can contain multiple elements such as resistors, capacitors, and inductors. They can be connected in series or parallel. We're going to start by looking at series AC circuits. All three of the above mentioned elements can be expressed in terms of an impedance, which is given the letter Z. Each element has a formula associated with it to calculate the impedance. These three are shown below. The individual elements can then be replaced in the circuit with their impedances as shown. The total impedance is then given by the sum of these. Calculating the voltage in a series AC circuit is done by using a modified version of Ohm's law as shown here. An example is given here for a circuit of current 1 amp and the given impedances. Here's how we're going to tackle this question. So we use our modified version of Ohm's law given from the previous slide. We substitute in our values of impedance, which gives us a complex number in the rectangular form. We can then convert this to polar form to give a voltage with magnitude and a phase angle. Now moving on to parallel AC circuits. As with series AC circuits, all elements can be represented in terms of impedance. That means the elements can be replaced once again with their impedances in the circuit. The total impedance is then given by this formula, where the reciprocal of the total impedance equals the reciprocals of the individual impedances. Each individual impedance can also be expressed as admittance, which is the letter Y. It's a measure of how much current is allowed to flow by the element. This means that the total impedance can also be expressed in terms of admittances. In series AC circuits with multiple components, each component will have a voltage drop. To find the voltage drop against a given component, we use this voltage divider rule. An example of this is given below. To find the voltage across the resistor with the given impedances, we use the voltage divider rule, input our given values of impedance. We can then convert the denominator into a phasor to make the division much easier and get our final answer. In parallel AC circuits with multiple branches, each branch may have a different impedance due to different elements. To find the current in any given branch, we use this current divider rule. For a two-branch circuit such as the one shown, the current in each branch is found by the opposite impedance over the total impedance times the source current. That brings our presentation to an end. Thanks everyone for watching.